it's called a lab, but it really isn't going to be a lab that you submit on the computer. It's going to be, it's more of an in-class activity. It says we're going to take a sample of the students in the school, and the school is down here. And we're going to take a sample of those students, and we're going to let you take a convenience sample. Going to let you take whatever you would consider to be a good, unbiased, random sample. Okay? But you don't have a method for making sure that it's random, so you're going to make your choices. Now, this is the purpose of the study. You want to take a survey regarding kids and sports. You're going to be allowed on the playground at the school to ask your questions, but you only have a clipboard and a pencil to record your answers because you don't want to try to show the kids any math during recess. So you're going to walk around with your questions and your clipboards and just write their answers down. You need to survey 8 students. We don't want to survey all the kids. You don't have time. We want to survey 8 students. These students are in these teachers' classes, and they're all out on the playground at the same time. All of these students here are a representation of the population that we want to sample from. You're only going to pick 8 of them. Label the ones A through H that you choose for your sample. And then once you label those students, tell me why you picked that student. Don't overthink it. Just pick 8 students and tell me why you picked each one of those 8. There is no right or wrong way to do this. You get finished with your 8, put your pencil down and look up so that I'll know everybody's finished. If you're not at least halfway through this, you're overthinking it. That or you're worried about that you're going to make the right grade. There is no right grade on this. There is no good or bad or right or wrong. This is what you want to choose for your 8 kids to ask them questions about sports. And your answers don't have to be detailed. You know, you can say jump rope or crazy hair. Cute. most people are mostly done. Let's talk about this. Who picked this one? Anybody?
Yeah.
Okay. Would you be willing to share why you chose that student?
So just having fun on her tricycle.
They were on the bicycle.
Yeah, because it was in the lower left-hand corner. It was easy to circle.
Okay, that's a good convenient sample. But usually I get an answer like bicycle. Okay. Who picked this one? Anybody? No? How about this one? Why'd you pick her or him? I'm not sure what it is. Why that one?
Swing.
Swing? Okay. How about this one? This one right here. Who picked that one? Why did you pick that one?
Running.
Running.
Running. Got my letters mixed up. Who picked this guy? Or whatever. Why?
Got big guns.
Muscles?
I was thinking of that song Flex.
Yeah. Who picks this one? Okay, why him? Or her?
Mean looking.
Mean looking, okay. How about this one?
I'm hungry, and he had a lunchbox.
Okay. Who picked this one? Why'd you pick that one?
Straight hockey.
Okay. Hockey. Who picked that one? Why?
We're having fun on a wheelchair.
Excuse me?
Having fun on a wheelchair.
Okay, wheelchair. It's a survey about sports. Why choose somebody in a wheelchair?
Diversity.
Okay.
Yeah, Joe.
Now, every one of you chose a sample that was biased. It's impossible not to. It's human nature. Look at the reasons you chose the ones you chose. Even though you had the best of intentions here, you were trying to be diverse. Would you also have chosen this one for the same reason? Anybody choose that one?
I thought that was the teacher.
Okay, and that's usually the answer I get for that one. I thought that was the teacher. Well, no. Those are all students. And you're only going to survey students, and that's why I said, these are the population of students. And it should be somewhat obvious that this is not the teacher because that's Mr. Gregory's class. Unless Mr. Gregory wears high heels
And a skirt.
and a skirt, that's probably not Mr. Gregory. Okay? It is impossible for a human being to choose a representative sample from a population, no matter how large or how small, because we all, even when we're trying not to be biased, we're trying to be unbiased, we wind up being biased because we're trying to be unbiased. Okay? We just can't help ourselves. That's a convenience sample. And that's why convenience samples are not good. Now go to the next page. We're going to learn to take a simple random sample. In order to do this, you are going to need access to a calculator. On your phone, on your iPad, on the computer, whichever you want. You will need access to the calculator. How many total students are there in this school?
34.
34 students. Now, in order to make this easier on me, I'm going to use the big list. I want you to number those students 1, 2, 34. However you want to. I'm going to number mine without showing you how I numbered mine. You can number yours however you want to. You can number them by the class. You can start here and go this way. You can go up and down. You can go back and forth. But remember, you're going to have to be able to locate these students. So have some method in mind when you number those students. There is no right or wrong way, but you do need to number them all. Everybody got their kids numbered? 1 through 34. Okay. The calculator command used to take a random sample of 8 from this school would be this. I'm going to write down the words, then I'm going to show you the steps. I'm sorry, not 1/8, 134. One comma 34. Now here's the steps. I'm going to write them down, then I'm going to walk you through them. You're going to hit the math key. You're going to right arrow 2 times to get to the PRB menu. Then you're going to arrow down. Number 5, Rand-Int. And then once you get to the home screen, once you do this, it'll say Rand-Int. And then it'll have the parentheses, so you're going to put a 1, a comma, a 34, close parentheses, and hit enter 8 times. I'm going to step you through it. Math. Over to PRB. Down to number 5. Hit enter. 1, comma, 34, close the parentheses, and hit enter. Now, I've only hit it 7 times because it's going to go off my screen and I'm going to need to circle my students now. Okay? If you get the same number twice, you cannot count that student twice in the survey because you don't want that student's answers to count twice. Although, realistically, if you are sampling without replacement, that's what that's called. You really should sample with replacement so that it's actually potentially possible, though not likely, that you would choose the same student all 8 times. But you can see for practical reasons you really don't want to do that. So I want you to randomly choose those 8 students, and they have to be 8 different students. You need 8 circles. Okay? Yes.
Is that a 5?
That's a 5. The command number is number 5, Rand-Int. Okay, let's use this one. It works exactly the same as it would on your calculator.
And what happens if you get the same number twice?
You can't count that kid twice. You just simply select an extra student. You have to have 8 different students, so you just hit enter another time.
Makes sense.
What did you put after enter? The 1 to 34 and enter?
8, at least 8 times. It might have. You just keep hitting enter until you get 8 different numbers. Okay. Okay. So the students that I got, and I'm going to circle mine. I chose student number 33, number 31, number 5, number 18, number 14, number 25, and student number 2. So I have 1, 2, 3, 4, 5, 6, 7. I need one more. And that will be number 12.
What do you think the odds are of us getting the exact same answer?
Because I told you you could use the calculator on the computer and I didn't have you seat it first, it's a pretty good chance that you would get the same answers as somebody that's sitting next to you. If you use your calculator and your calculator's never been seated, you will get the same answers as anybody else that their calculator hasn't been seated. And what I mean by seated, and I'm going to show you all how to seat your calculator here in a minute so that you will not, after this one, get the same answers. The random number generator actually is a program within the calculator. And it comes preset to start at a specific number. And then it counts off or increments by whatever you tell it. You know, whatever you set the selection to be. And since it's preceded to the same number as everybody else, the program goes to the same exact ones every single time. So between now and the next sampling thing, I'm going to have you all to reseed your calculator. I'll show you how to do that.
Go back to the formula.
Would it be better if I wrote it on the board for you? Okay. These are the steps. And at that point, this is what you see on your screen. And then you type 1, and then a comma, and then 34, and close parentheses, and hit enter. And you hit enter until you get 8 different numbers. Does that help? So I've got my 8 students. And it may strike you that, you know, if 1, 2, 3, 4, 5 of those 8 students happen to be doing what you thought of in the last time as doing sporty stuff. And notice that in my case, maybe not yours, but in my case, the little guy with the wheelchair got included. He might not have, and that would have been okay. This time he got included by chance, not because I was trying to force it. Because he's only one of 34 students. If he's only one of 34 students, and you were truly random in your selection of students, he should only have a 1/34th chance of being included in your sample. So if you were trying to be unbiased and you included him because of diversity, then guess what? That was a big violation of that because you overrepresented his category. Now, truthfully, if you go through and you count the students that appear to be sporty kids, my sporty kids in my random sample are slightly overrepresented, but not by much. Because if you go through and count those, quite a few of those kids actually are doing things that you might consider to be sporty things. Okay? But this is a random sample. Did anybody in here choose the exact same sample I did? Okay, there's that seeding process. So in order for that not to happen, because you shouldn't be choosing the same one that I chose, you shouldn't be choosing the same one anybody else in the room chose, here's what we're going to do. And you only have to do this once. This is the only time you ever have to do this. Get your calculator, whichever one you're going to use, and if you've got a handheld but its batteries are dead or you didn't bring it today, that's okay. You will need to do this before you use it the next time. And in that case, you can bring it up and ask me, and I'll show you how to do it. But what we're going to do is I want you to type in the last 4 digits of your cell phone number. There's very little chance of anybody's cell phone number having the same last 4 digits in this room. Then I want you to hit the store button, which is right down here next to the number 1. Okay? Makes a little arrow. Then I want you to hit math, go over to the PRB menu, and just hit enter on rand at the top. Now that has reseated my calculator to where it's going to choose as its random starting place 2902. And it'll cycle from there back to the group of numbers that I tell it to choose between. But it's got its random starting point now, and it's different from yours. So those of you that raised your hand a minute ago, randomly choose one more of those 34 students. And you can do this by hitting second enter twice. And that way you can just repeat a command. That's just a nice little shortcut to know. And hit enter. Did anybody else that got the same sample I did a minute ago, did you all get 21 now? Now, it is possible somebody else in here would have picked number 21. Because there's more than enough people that could happen. But there's very little chance that you pick 21 and 28 and 34. And the more I go, then the less likely it becomes you chose the same 3 students that I did, or the same 4 or 5 or however many. Okay? So we should all be getting different random numbers now when we do this. So that's how you take a simple random sample. You have to have, in order to get a simple random sample, remember this. In order to get a simple random sample, you have to have access to the whole population. If you have access to the whole population, why would you not use it?
Why wouldn't you use the whole population?
Right.
Well, it takes too much time.
Okay, time issues. How likely are you to have access to the whole entire population easily?
Depends on the population.
That's right, it depends on the population. If I was talking about the population of all the seniors in all Tennessee high schools this year, I could have access to the whole population. That's a pretty big population. I could get access to that whole population because those students have records that are maintained by the school systems. I would have to get a lot of clearance because those records are protected by federal law. But if I wanted to know something about that population and it was strictly for research purposes, I could get access to that whole population. But they're spread all across the state of Tennessee. Why would I not want to include every single student? Suppose I want to interview every single student.
A lot of time and resources.
A lot of time, a lot of money, a lot of resources. So there might be a better way to get access to all those high school seniors. Okay? Random might not be the best way. Even if I have access to all of them, and I can number them from 1 to however many, having to actually sit down and interview each one of them is not a really easy thing to do. So a random sample might not, a simple random sample might not be the way to go. And that word simple is very, very counterintuitive because simple says, well, this would be easy. Well, no, it's not. A simple random sample is the hardest sample in the world to take. Now, I could take a simple random sample of all the students at Northeast State and actually sit down and interview those students. I would send over to the registrar's office and say, I need a random sample of the names and the class schedules of 50 students. She goes in, feeds a command into the database system and says, I need a random sample of 50 students, and she'll send me a list of those students and their class schedules, and I'll be able to go around and talk to all 50 of those students. It'll still take time, but I'm sure not going to try to talk to all 6,000 of you. Okay? It would still take time. Or I could ask just for the addresses of those students, or the emails for those students, and then I could actually email out my questions. But I'd still want some form of absolute guaranteed contact because I don't want that sample to be self-selecting. I don't want a student to say, I don't want to talk to you. I want them to have to be face to face with me and answer my questions.
You want me to keep this, just hold on to it.
This,
This is what we're working on now.
okay.
You just want me to hold
Yeah,
on to
hang on to it. Watch the rest of the recording to get the rest of it,
Yep.
and you'll be able to kind of follow along and have that.
Okay, is there anything else I'm gonna miss?
Don't think so.
Okay,
Don't think so, because this usually takes most of a class period.
thank you.
But it's the best way to learn how to do this.
All right.
Okay, so this is a simple random sample from a population of 34. Okay? Let's go to the next page. Now we're talking about a systematic sample. The analogy I like to use for a systematic sample is a file cabinet sample. If the population I'm interested in, all of them have a file in the file cabinet, I would randomly select one of the 4 drawers in the filing cabinet, and then I would open that drawer, and I probably could figure out about how many files are in that drawer just by gauging how much space the first 10 take and go from there. So I could probably get a pretty reasonable estimate of how many files are in the drawer without having to count them all. So then I would randomly choose one file in that drawer. And I would pull that one up and lay it aside because that one would be in my sample. And then I would hold the place, and I would have a predetermined increment. Maybe I'm going to take every 8th file. So with that file being number 1, then I'll count 1, 2, 3, 4, 5, 6, 7, 8, and the 8th one comes out and adds to my pile. And then from that one I count 1, 2, 3, 4, 5, 6, 7, 8, and the 8th one comes out and goes to my pile. Until I've gone through every single drawer and come all the way back past the first file that I selected. Then I've gone through my whole population. Okay? That's kind of what this is. We are going to make a systematic sample of these students. There are still 34 students in this class. So we are going to number the students again, 1, 2, 34. We're going to randomly choose a starting place, which means we are going to rand int 1, 34, just like we did before, once. And since I don't want them, now I guess I'll go renumber my kids. So you number yours and you randomly choose your starting point. Okay, my starting place is going to be student number 24. So that's how I marked my starting place. Okay? Put a big arrow over that student's head. That student is not part of your sample. That is your starting point. That student may become part of your sample depending on the increment that we use to count off. But that student, the reason we don't count that student is simply a starting point, and we have to pass that student and go through the whole population to get our students for our sample. Now, the rest of the instructions say, pick a number between 5 and 10. I'm going to let you choose, or you can randomly choose a number from 5 to 10. If you want it to be more random, then you randomly choose a number from 5 to 10. This gets the randomness throughout your whole sample. So my increment is going to be 9. That means I'm going to choose every 9th student. I'm going to circle the students as I go through and stop when I have a sample of 8. So starting here, this again is just my starting point. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my first student. Then 1, circle back around to the beginning, 2, 3, 4, 5, 6, 7, 8, 9. There's the second element in my sample. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my third kid. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my fourth one. 1, 2, 3, 4, 5, 6. That one can't be chosen again. It's already out. 7, 8, 9. That's number 5. So you don't count the ones that you skip over the ones that you've already pulled out for your sample. They're not in the pool anymore. So then 1, 2, 3, 4, 5. Skip that one. 6, 7, 8, 9. That's number 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number 7. Then 1, 2, 3, skip that one, 4, 5, 6, 7, 8, 9.
Do you skip the starting point?
You only skip it the first time. That's student number 1. And then you just keep on counting, and the starting point is one of the students. You may wind up selecting that student. That student is not your first student. Okay?
Select 8 in total.
Excuse me?
Get 8 altogether.
Yeah, you have to go through until you get 8. Now, the reason that you were told to choose from 5 to 10 students is because the increment of 5 will make sure that you go all the way through the population at least once. If you only chose every fourth student, you might not get through the whole population before you got your 8. So you want to choose a number that's big enough to get you through your whole population. Either that or plan on taking a bigger sample. Because you do want to represent your whole population. Now, was this biased in any way?
No, absolutely not.
It was absolutely not biased. It was random. We randomly chose the starting point, did not include that starting point. I randomly chose an increment. You could have done that too. Randomly chose the increment and then counted every so many student after that. And even though we didn't choose the first student to be the starting point, that student kept getting thrown back into the potential students. Okay? There is a disadvantage, even though this is a relatively random way to choose a sample. I'm not going to call it a simple random sample, and I'll explain why. There's a distinction actually between a random sample and a simple random sample. It is a random sample, it's not a simple random sample. The disadvantage to using this method is if your sampling units are arranged in some kind of order, then you may skip over somebody that should have been represented that wasn't. And to make that a little bit more clear, suppose we go back to the filing cabinet thing and all those students are arranged in alphabetical order by their last name. Your chance of getting chosen if your last name starts with a Z or an X, not real high. Your chances of being chosen if your last name starts with an S or a T, a lot higher, because there's a lot of Smiths, a lot of Thompsons, a lot of Trents, not very many Zhangs, not many Zalins. Okay? So if you have a population that is in some kind of order, that's probably not a good way to do this. You want to mix that population up first and then do your systematic sample. But this is a relatively random sample, meaning that every student had a chance to be included in the population, or excuse me, included in the sample. Every student in the population had the same chance of being able to be in the sample until you chose the starting point. Because once you chose the starting point, the whole rest of the sample is predetermined. Because you have a set method for choosing the rest of them. So once you choose the starting point, then the rest of the students are absolutely already determined, and that drops the other students down to nil for being chosen. But because you randomly choose the starting point, every student in that population had the same chance of being the starting point. That means that every sample of a given size has the same chance of being chosen. And that's a random sample. In order to be a simple random sample, every element in the population has to have an equal chance of being in the sample, and every sample of a given size has to have an equal chance of being selected. Okay? Those two things have to apply.
Are there some measures of the quality or probability of the quality of particular sampling methods? I mean...
there are, and in graduate level statistics classes, you actually have to learn how to control for the sampling method that you used. There's a little bit different formula to calculate those probabilities depending on the kind of sampling method that you used. We won't get into that. We'll just say that this is a random sample or this is not a random sample.
But you always are striving to make your sample statistics truly representative of the population.
Exactly, and that's most likely to happen with a random sampling method. Definitely not with a convenience sample. Okay? You can also control for other aspects of the population with some of these sampling methods. We're going to talk about that probably in the next one. So does everybody understand how we do this one? How this one works? So this is called a systematic sample. Let's go to the next page. We're going to take something called a cluster sample. Cluster sample. We're going to consider each class to be a single group. That means there are 1, 2, 3, 4, 5 groups. So we're going to number the classes 1, 2, 3, 4, 5. We're going to use the calculator to take a random sample of 2 classes. The calculator command is going to be rand int 1, 5, and we're going to choose until we have 2 different classes. Hit enter too soon. Okay, so I'm choosing class number 2 and class number 3. It is quite possible that you chose the same classes that I did because we're only choosing from 5 different numbers. So those are my students. I have a sample of 13 students. If you chose this one and this one, you have a bigger sample than mine. If you chose this one and this one, you have a smaller sample than mine. So one disadvantage, if you would want to think of it that way, one thing that you can't have assured is a certain sample size by doing this method. But it was random. Notice I didn't say it was simple random. Because every kid did not have an equal chance of being selected for the sample. Okay? Every class had the same chance, but not every student. Every sample of a given size, no, because I'm not guaranteed a sample size here. So this is a somewhat random sample in that I chose all of the people in some of the groups. And that's a key word you want to keep in mind with cluster. Cluster is all of some. Okay? All of some. Now, when would this be a good method to use, despite the fact that it's not very random? It's somewhat random.
Well, it would be easy to do, convenient somewhat. You just have to focus on, you wouldn't have to wait for the playground. You could just go to the
Right, you
class.
could go to the classroom. It would be much more convenient to visit just those kids in their classroom. Now think about my high school seniors example that I started out with. All the students in all the high schools all the way across the state of Tennessee for this academic year. And I want a random sample of those students that I have to actually sit down and talk to them. What would be a good way?
Yeah, cluster.
A cluster sample. I could go by counties and randomly choose, I don't remember how many counties there are in Tennessee, but choose 10% of the counties. Yes, I would still have to travel, but I wouldn't have to hit every single high school. Okay? And I might use technology and do FaceTime with students in that school. And it would still be easier. So yeah, a cluster sample might make sense. What will be the downside to using a cluster sample? That might be a bias.
Oh, you're just going to say what I was going to say.
Okay, but it might be biased. Why?
Demographics with the, the population, students, they could be predominantly Hispanic, predominantly white,
Yeah, it depends on the area. You hit
Depends on the
Carter
area.
County as opposed to Knox County, maybe.
Okay, now they don't do it in school. Well, they do still to some extent in this in public schools. What if it just so happened that this class was the students that had learning disabilities?
Skew your results.
It'll skew your results. So if your clusters are not demographically similar, cluster is a bad sample, because sometimes a certain population could be over or underrepresented. Okay? So yeah, could be problems with this one. This is not a good sample to use without a good justification for why you used it and consideration of all the different factors that might cause it to be bad. Okay? It is a somewhat random method, but it seems much more random than it is. Now we're going to talk about a different kind of sample called a stratified sample. And remember the last one I said was all of some? This one is sum of all. This time we're going to be sure we get some students out of each class. Instead of numbering the classes, we're going to number the students within each class, but we're going to start over again at every class. So, I don't need the calculator right now, so I'm going to get it out of the way. This is how you need to number the students. And you don't have to number the students within the class the same way I do, but you do need to start over with number 1 at the beginning of each class. So these students are going to be 1 through 7. And these are going to be 1 through 7. These are going to be 1 through 6. And this is 1 through 6. This is going to be 1 through 8. And then what I'm going to do next is I'm going to randomly choose some students from every one of those classes. So we're going to take a random sample of 3 students from each class. So class number 1, the teacher's name is Mr. Smith or Mrs. Smith. The number of students in that class is 7. So I will do rand int 1, 7 3 times. Let's start with Smith. So student 1, 2, and 6. And then my next class will be Johnson's. And that class has 7 students in it. So it'll be the same command. And 6, 7, and 3. next one will be carries. And there are only 6 students in the class, so my command changes. Randit 1,6.
What happens if you get a duplicate?
Just get another one. Hit enter one more time and choose a different student. Then we have Gregory. And there are 8 students in this class, so it's going to be Randin 1,8. Student number 5 was very determined. So, oh, I got one too many. 5, 3, 4. And then the last one, I'm back to 6 students. That's Turner's class. Six, 5, and 3. And then I made the note on your handout at number 5. I chose to select 3 from each group. You don't have to choose 3 from each group. Since some of the groups were larger than others, you could have chosen 3 from the class of 7 and 8, but only chosen 2 from the classes of 1 through 6, because they're smaller classes. If I were doing a stratified sample and selecting people by freshman, sophomore, or by the number of credit hours they have, I would want to group you by the number of credit hours you've earned or your progress on your degree goals. And I would want to maybe take more from the larger group. One group might be further along in their career and there might be more of them, or there might be more people, this is their first semester here. So I'd want to take a larger sample from that group. Okay? That would allow me to control for any mismatch. That would allow me to control the demographics. Okay? Is this a random sample? I didn't say simple random sample. It doesn't have to fit both. Is it a random sample? Yeah. Because I chose a set number from each group. Even if I didn't choose a set number from each group, as long as I chose the same samples every time, the same number from each or from similar groups, then I would still be selecting for a particular sample size, and every sample size has an equal chance of being selected. Okay? This is a good way to do simple random sampling. Not simple. You still have to have access to your population. But if you're trying to control for demographics, this is a good way to do it. Was every student afforded the opportunity to be in the sample? Yes. Was every student afforded the same opportunity to be in the sample?
No.
Why not?
Because some of the classes are larger.
That's right. Some of the classes are larger than others. So you had a better chance of being chosen if you were in the class of 6 than if you were in the class of 8. Because in the class of 8, you had 7 7 competitors for your slot, whereas in class of 6 you only had 5. Okay?
So maybe instead of taking the same number, you should take the same percentage of kids, of people.
That would be a way to control for that, yes. You could choose to do the same percentage from each class. Now, with small groups like this, that's still, because of rounding, might be a little tough. But if you have a larger group, then it's easy to proportion your sample among the groups.
So Solomon had a way to take care of that.
Oh, yeah. His was a little destructive to the sample, though. Okay, does everybody understand the different methods of sampling now? Now, if you go through and you just read about those sampling methods in the book, did you understand as well what they meant? No, you have to actually do it, or you're not going to remember what the methods are. This is for next time. This is your homework assignment. Take this home, look at your handout, bring it to class next time with your thoughts on the answers to these questions.
I don't know why, but it never makes its way over to this area, because I haven't signed it in a couple days.
Okay. There, just write it on there. Let me try something on the machine if you're on the book. It may be that machine. Is it everywhere in your school? Okay, it may be that machine. Let me see if I can fix it. And while I'm doing that, maybe log into one of the other computers. Get that in? I have a question. Okay. What did you do? You fill out the long one? Yeah. Managed to hack through yourself.
Oh, yeah, okay. I'm not really sure. I just want to know.
Yeah.
You can go ahead.
That first Monday? Did you check E2L email? Because I think I sent you a link. It didn't work? Somebody else told me that would work, and that's why I tried it that way. Okay, let me load that up, and let's put that video up into this class. The link is for my 1630 class, not for this class. But it's, I mean, as long as you ignore the fact that it's a different website, the information is the same for all of them. You're welcome.
Okay. I didn't get a Yeah, I didn't get a
Yeah.
Do I need to show up?
Yes, I got 2 hours. I got just in
All right, and that's from
time.
5:30 to 9:30, right? So I
Right.
can be here at 7.
Come to 7:30-ish.
Okay.
Because we don't necessarily, I reserve about the last half hour. That's a long class. So I reserve about the last half hour of that class to just go around and work with students individually and take questions and stuff.
Okay, so I'll show up around 7.
Yeah, you should be able to get everything that way.
Okay, sounds good.
Is there anything like you would want to like maybe print off for us to go ahead and do since we keep getting this era and stuff?
Is the iPad the only access you've got?
Pretty much, yeah.
But I've done it on my computer, I've done it on my iPad, I've done it on my phone, I've done it on my computer, none of them will let me log on to it. I get the error message on all of my stuff.
I'll extend due dates because I really don't have a way to give you access to what you need access to until you can actually get the error fixed.
Yeah.
But that's why in class I'm doing a lot of pencil and paper stuff or doing near part and things like that. So right now don't worry about it and I will extend your due dates.
Okay.
That's why I wanted
I don't
to.
want to freak out.
No, you'll be okay.
Because I almost
promise.
wasn't here because I've been in the hospital. I'm not even supposed to be here today.
Oh.
That's still came. So, yeah. Trying to blame it on that, what's it called, that old people get because of my age. Vertigo.
Oh, Honey, you don't have to be old to get that. I've got a friend that's probably younger than you that has it.
Yeah.
But when it gets to her, oh, it's bad.
I don't know, like, I don't drink, I've drank in years, but it just felt like
Yeah.
the room was good. I
Yeah.
couldn't even walk. It was awful.
Yeah, the girl I know, Rhonda would get so sick when she tried to walk or stand up, and she just had to lay on the couch.
Yeah.
She couldn't move, couldn't drink.
It never happened before.
Yeah, it's one of those things that it comes and goes, but when it comes, oh boy.
It never happens again.
Oh, I don't blame you. I hope not too.
The flashcards don't have it in these classes. I know some classes they said, ask your professor if they need it, or you can opt out. So, the ebook, yeah, like the textbook.
You cannot in this class.
Okay.
You cannot. If you do, you will wind up paying an extra $50 to get back into the My Stat Lab part of it. It's not the book that you need, it's the homework that you need.
Okay. All right.
Okay?
Thank you. Yeah. This isn't happening yet.
Oh,
This, okay. I didn't think it would happen. I figured if I've already done it, I've already been in it. I
Did you make a note of that on,
didn't send that homework person, but I tried to figure it out.
put your name on the class list and write me a little note and tell me what the problem is. Because I won't remember between now and when I send the list to the
Now, grunt stuff. That's the temperature thing, you know.
Okay, grunts, okay.
I don't know if you might know, but based on one of the definitions, one of the questions, I know the question on this, and there was a, I do have no answer to the question. So it says, numerical data, but only the difference between two data values is meaningful, and there's no natural series ratio. That's integral, right?
Yes.
I must-
Zero doesn't mean nothing. It doesn't mean absence or nothing. Okay?
Because they had a question about chemicals, you're looking at
Right.
yeah.
Right, and besides that, if you think about it, even if you subtracted and got a difference of 2, if you're looking at 2 different patients, what does that mean? I mean, you know,
It's meaningful if that's what they do this scale, it's different between.
it's different between every person.
Yeah.
So really, that person is just putting a qualitative connotation on it, but they're doing it with a number. So a pain level of 1 is definitely not as bad as a pain level of 10, but you can't say that, well, this patient's a 10 and this patient's a 10, therefore they have the exact same pain level. Depends on that person's perception of the pain.
You want
Okay.
to upstairs, what time is it?
I'm going to go get something to eat. I should be there by 2:30.
Where are you going to eat?
Don't know yet.
Okay, I'm just going to run to the bookstore, and I'm going to the office.
Okay,
I'm just going to be there 5 minutes. So.
okay, that'll be fine.
I think I know what you mean by question 3, but I think the phrasing was very confusing to me at first, and I think this is what you meant.
No, I actually meant this. Which sample of every possible sample of 8 students in the school have the same chance of being chosen.
Every sample has the same chance to
Just the sample, not the individual students, the sample itself. And there's only one.
every sample, every possible sample. Okay, by sample you mean the set of things contained in the sample.
Right.
I don't think I understand.
Well, and it's confusing. It's a fine point. The difference between a random sample and a simple random sample is that in a simple random sample, both every student has to have an equal chance of being selected, and every sample of a given size has an equal chance of being selected.
The sample is what's selected.
It is, but it could be a different 8. Does this sample of 8 have the same chance of being chosen as this sample of 8? And there's only one way that happens.
This set.
It has to have a set sample size.
This set has an equal probable chance of some other set that might contain some of the same students. Because I don't understand.
It could contain some of the same students, but maybe not all of the same students.
I don't understand. Totally don't understand.
Okay, think about it this way. Let's go back through your samples. Every sample of 8 students had the same chance of being chosen here.
Okay, so throughout the class, we had some 25 or so different samples.
Right. And there's actually way more than that. When we get to the counting methods, you'll be able to say how many different samples you could have taken with that number of students. It's kind of astounding, too.
Well, it would be your starting point, whatever your starting point was. Wait a minute. And also the interval.
Well, this is the simple random sample.
A simple random.
This is the simple one. Every student had the same chance of being selected, and every group of 8 students had the same chance of being selected.
Every group of 8, every possible set of 8
Right, every possible set of 8. That's a good way to phrase it.
had the same probability as any other set of 8.
Yes. Okay? So that's true. Both of those are true here, and that's why it's a simple random sample. We did not have a set sample size here, depending on what that increment was. So
Yeah, you chose the increment, so if you could vary the increment, then that makes it, how in the world?
So that one doesn't fit. That one, you don't have the same sample size every single time, depending on the increment you choose.
But if you said you stopped at 8, then every sample would have the same size. Instead, you say keep going until you got 8.
You keep going until you got 8,
So I
but
mean, the sample size is always going to be, but it may not cover all the people if your sample was too small.
yeah, if your sampling increment's too small or too large,
Or too large.
then you may not get the sample size you want, and then that creates a problem with the randomness. Even though that's a good sampling method for some things. This one, there is no set sample size.
That's probably because you could, in the case of your thing of schools, some of the high schools are very small, the rural ones, and some of the urban ones are very big.
Right. So, if you choose, you would want to be sure you had a way of choosing larger and smaller. If you choose by counties, that's more likely to happen, rather than by school systems. And for this one stratified sample, we could have set it to where every sample of given size has the same chance by taking as we did here, the same number out of every group. Only this one, the question specifies 8. This happened to wind up being a sample of 3, 6, 9, 12, 15. Okay?
All right, let me go back and look at this question again now.
Okay.
Okay.
Yeah, what you're struggling with on that question is the distinction between every student having the same chance and every
Group
having the same
every
chance.
possible set.
Yes.
Every possible combination of sets or combination of a set.
Yeah.
Okay.
Okay.
Yeah, okay, I'll cross out my correction and go back to your original.
Okay.
On the 24th, I wasn't here because of schedule problems. They printed out my schedule, and when they handed it to me, they didn't hand me 3 sheets. It was printed on 3 sheets, and I didn't know I was supposed to be here Wednesday.
Okay.
So I know that we have homework that's online and everything. I just wanted you to know that that's the reason I wasn't here. I
Okay.
wasn't just not showing up.
Okay. And I may not have even gotten that you weren't here on Wednesday because last week was
I
just
wrote it on
a
the
little
board
crazy.
there.
Okay.
Because on the
But
22nd.
you had the 5 assignments that you sent in?
Yes.
Okay. And
Or the 5 videos. The 5 assignment number 1 for the
yeah, that has the 5
the
different
5
parts.
things.
Yeah.
And then I watched the videos already.
Okay.
And then I know that the homework for chapter 1 was due September 5th, right?
Yeah. Not the homework, I'll have to go back and look at the dates. It might be September 5th.
Okay.
And anyway, I'm probably going to change some of them because so many people are having trouble getting them.
Yeah, I couldn't log in at all yesterday. It wouldn't let me log on. Like, to to my northeast at all.
Okay.
Thank you.
That's what trouble we need to know once that type error.
Okay. It's only here.
It's been working on this as of
Okay. It's interesting that it's only here. I mean, it's not just on one computer.
No,
It acts
yeah.
like you're not even.
Yeah, I don't know. But it lets me sign in. It's just once I get to that
Well,
agreement page.
and when I go in, I'll go look at your name and see, make sure that it's showing your homework.
Because I have done homework 1 and I've done quiz 1, which I stopped retaking the quizzes because I'm not understanding the measurements, but I'm going to continue to redo that one. The
Okay.
homework isn't, it'll let me completely redo it too, right?
Yeah.
All right, thank you.
Homework and quizzes both. Are you in my class? or-
No, I'm just for the next class. Thank you.
So, I still argue with your phraseology. Because you say, in which sample? And I would say, in which sampling method
Okay.
did every possible sample?
Well, and that's not my phraseology necessarily either, because we all share handouts.
Okay. In which
Yeah,
sampling
you're right.
method?
It should say which sampling method did.
And I'm having trouble scratching my head trying to understand what we're asking is your method giving you a set of 8 that is truly random? Is your set truly such that every combination has the same probability as every other combination?
Yes.
I have no idea how to assess that. I don't understand how to assess that. It's not obvious.
It's easier to figure out when it isn't than when it is.
When it wouldn't be equally likely. But it seems like if it's truly random, then every set has to be equal probability.
Well,
if it's a truly random
Yeah,
sampling
and that's
method.
what this one is. But then again, it says it's simple random sample.
Simple random sample. Wasn't that the one where we just randomly selected people? But
You
then-
randomly selected, but you selected a particular number of people. So you number them off.
Oh, yeah, you
and
calculator
ran-
going to take a random. Yeah, the calculator told you which one to use.
Right.
Yeah.
This one, you were supposed to do it until you got 8 students. So by randomly choosing a starting point, every sample of 8 students had the same probability.
Did it? I guess I have trouble calculating probabilities. I have no idea.
Okay.
I really had to calculate.
Look at it this way. What if I had chosen, instead of this student, what if I had chosen that student for my starting point and still using every 7th student? I would go 1, 2,
Sure.
3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 8. Some more. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7.
I guess my problem is that
So with a different starting point, I chose a different 8 students.
it's always been kind of a mystery to me. Not a mystery, but not totally intuitive. Like, I know that I've been told that if you have a room of 50 students, 50 people, the probabilities are 50% that some 2 people are going to have the same birth date. And there's 365 possible combinations. So I know figuring out probabilities is not as simple as it seems.
No. No, and if you're struggling here, you'll be very challenged in Chapter 4, but then Chapter 4 challenges me sometimes. Because that's the study of probability.
Yeah. Well, that's why I'm taking this course, is to better understand, and I participate in a research net, and A couple of times, people have asked for volunteers to assist in some of the research going on. I couldn't really do too much because all I could do was, I helped one of the PhD guys by translating some stuff out of a table. I was able to suck it into an Excel spreadsheet and give it to him and really helped him. But understanding that's why I'm taking the course, so I can understand these things better.